Thank you all for being here. I want to start with the question of what are poly and perfluoroalkyl substances, which is a question that I asked myself a little over 20 years ago when I was standing in the kitchen of my apartment in Massachusetts about ready to drive across the country and start graduate school. I called my soon-to-be advisor, 𝗣𝗙𝗏, and said, I've got a long drive ahead of me. Should I be thinking about anything before I start graduate school? And he said, well, another faculty member here at Stanford has told me about these chemicals called perfluorochemicals. I don't know what they are. I don't know exactly how they behave. But he says they share some of the same properties in terms of sticking around for a long time that PCBs do. And when you get here, I want you to focus on these compounds and help us understand what these compounds are and why we should care about them. So I drove across the country thinking about this, and I got to Stanford about a month early, had a little bit of time to think through things. And I started studying this a little before school started, which I know is a little bit weird, but I wanted to get a handle on what these compounds that I would be studying are before classes started. And so, being the good consultant, I spent the next month really brushing up on what these compounds were. And I'd spent 3 years being a consultant before then, and dug in and realized that this was a group of compounds that are potentially really problematic. And they may be a very important issue, not just for my own graduate studies, but for many years beyond that. And so I stand here today in front of you, over 20 years later, still talking about these group of compounds. And now I'm going to explain why they're so important. So what are these per and polyfluoroalkyl substances? Well, on the left, we have perfluorooctane sulfonate, which is a perfluorinated compound where all of the carbon-hydrogen bonds have replaced with carbon-fluorine bonds. On the right is a polyfluoroalkyl compound, which has a perfluorinated tail, but also has carbon-hydrogen bonds. And that's important because those are weak links in these molecules. And whereas the chemical on the left can be described as molecular rebar, redefining the meaning of environmental persistence, the molecule on the right is a precursor to that compound and can transform in the right situation to the perfluoroalkyl compounds such as PFOS. So how did we learn about these compounds? Well, in the year 2000, 3M, one of the major manufacturers of these compounds, decided to pull PFOS and all of the precursors to PFOS from the market. They started to phase out their perfluorooctane sulfonyl fluoride chemistry. Okay? That was what was going on with respect to industry and communication with government. And that happened around 2000. Okay? In the peer-reviewed literature, there wasn't that much information out there really kind of understanding these compounds in terms of their environmental significance. One of the few studies out there was this 𝗀 and 𝗀𝗏 paper, which talked about these fluorinated compounds being present in the biosphere and what this meant. How did they behave out there? What did we know about these compounds out in the environment? And there was very little around 1997 when this paper was published. But if we look at the figure that they put out, it's actually quite illustrative of the sorts of things that we've been studying for the last 25 years. So many of these things, whether it's the behavior in groundwater, the behavior of these compounds in the atmosphere, how they're moving through sediments and soils into water supplies and into things like fish, these are things that were somewhat outlined in this paper 25 years ago. But again, a lot of the information was somewhat speculative based on the peer-reviewed literature. There wasn't a whole lot of information out in the actual literature documenting these compounds in the environment. There had been a lot of industry studies, but not out in the peer-reviewed literature. It turns out that one of the first studies showing that these compounds were present in things like groundwater was done by one of my longtime collaborators, Jennifer Field, at Oregon State, showing that these perfluorocarboxylates, which include things like PFOA, were present in the groundwater at sites that had been impacted by the use of firefighting foam, or aqueous film-forming foam, often referred to as 𝗣𝗙𝗏𝗏. And they detected these compounds in the groundwater, not through the use of liquid chromatography mass spectrometry, which is what we now use, but through the tools available to them at the time, or at least more broadly available. LC-MS was available at the time, but it wasn't as common in environmental laboratories. They used GC-MS, which was much more common in environmental laboratories. And so they detected these compounds in groundwater, and they pointed out virtually nothing is known about these compounds back in 1999. But we knew that these compounds had the potential to be out there. Okay, that was laying the groundwork for that. Around the same time, a really important study came out from some colleagues in Canada. And what they showed was that these perfluorocarboxylates and perfluorosulfonates have the potential to bioaccumulate in fish. So if these compounds get out into groundwater, they get released to surface waters, they have the potential to accumulate to higher levels in things like fish that humans might eat, and might result in an exposure to us if we consume the fish, but also exposure to the fish if they have some sort of effect on the fish. So the interesting thing here is that this slide illustrates two things that we don't generally talk about for the same group of compounds. That is that many compounds that are extremely persistent either stay in groundwater and don't really bioaccumulate. They might move with the groundwater, or they stay in a sediment and they do bioaccumulate, but they don't move with the groundwater. In other words, they're either mobile and not bioaccumulative, or immobile and bioaccumulative. The problem with PFAS is they are both mobile and bioaccumulative, and they combine both of those things together, which until this time, there hadn't been many classes of compounds that exhibited both mobility and the potential to bioaccumulate. So when I started my graduate studies, this is some of the first papers that were coming out about these compounds out in the environment. My very first study looked at these compounds in sediments and domestic sludge. And you have to remember, at the time, the tools to measure them, they were not quite where we are today. In other words, we were doing liquid chromatography mass spectrometry, but we didn't have nearly the availability of analytical standards that we now have. And so we were trying to find these chemicals and measure them quantitatively, but it was pretty tricky. But what was important in some of those early studies, and this isn't just my own work, but the work of others, is that we started not looking just for the perfluorocarboxylates and perfluorosulfonates, those that we knew were environmentally persistent, but we started including precursor molecules. And these are these compounds that have the potential to form the perfluorocarboxylates if they're released to the environment or are ingested. It turns out that this issue of precursors forming the perfluoroalkyl acids is something that actually had been documented many years before that. There was a study back in 1981 showing that these fluorotelomere compounds have the potential to be metabolically transformed to perfluoroalkyl acids in biological systems. So what this was pointing to is that when we're talking about perfluoroalkyl acids, whether it's PFOS or PFOA, we have to think about the precursors. It's not just about the perfluoroalkyl acids. Precursors are an essential part of the story that we need to consider when we're thinking about these compounds. So when we're talking about precursors, I really want to make sure everyone understands what I'm talking about when I'm talking about precursors. So what I'm showing here is a precursor molecule. It is a sulfonamyl ethanol, and it is one of the compounds that was produced for use in a lot of different products. This particular compound, though, is a polyfluorinated compound. And under the right conditions, whether a result of biological transformation or abiotic transformation, it can form perfluorooctane sulfonate, this molecular rebar which will persist in the environment for a very long time. The point being that if you're really interested in what's going on with PFOS or PFOA, you have to consider the fact that it is not just the PFOS or PFOA there that might be of concern, but the potential for precursors to these compounds to also be present and result in issues at your site or in your exposed population. So at the time, we knew that these precursors were potentially important, but it wasn't until 2012, with the advent of the total oxidizable precursor assay, the pure genius, I will say, of Erica Houts and David Sedlak, thinking that we could take advantage of the fact that these perfluoroalkyl acids are extremely persistent. They will not break down, but the polyfluorinated compounds will. And so let's take advantage of that and convert the polyfluorinated compounds to the perfluorinated compounds. And this enables us to measure many, many more compounds through the implied presence of them via their conversion in the top assay. And so the idea here is you take the polyfluorinated compounds, some of them you can measure, some of them maybe you can't, and you subject them to conditions that will oxidize them and convert them to perfluorocarboxylates. And then if you measure the sample before and after oxidation, you have a sense of the potential presence of these precursors. And just as a quick example, when we take a firefighting foam or a series of firefighting foams and we look at them initially without oxidation, we don't see very high levels of these perfluorocarboxylates in these foams. But when we oxidize them with the top assay, we see that they can form these relatively high concentrations of these perfluorocarboxylates. And this is really important because it speaks to the presence of these precursors even if we can't directly measure them. So these precursors are out there and they're important.